Hello dear students, we have already started our lesson chapter 13 which is a sound. Up till now we learn about what is a sound, the kind of waves. The sound is a kind of a wave, vibrating motion, the receiver, then the different instruments which used to produce a sound. Now in today's class we learn about the different properties of the sound like oscillation, time period, frequency, amplitude, wavelength. These are all the properties of the sound which we will see in today's class. So let's start with them. As we already learned about that the vibration, right? For the producing sound, the vibration is the necessary condition for that. So what is the vibration exactly? Vibration is nothing but the to and fro or back or forth motion of an object. So we know that the example of the pendulum. The pendulum is a continuously moving. It performs a to and fro motion. It performs a back and forth motion. So this is nothing but the motion of a pendulum is known as the vibration. Now related with this term, we learn about that the oscillation. Now what is the oscillation? How we count the pendulum performs how many oscillation? So the oscillation is nothing but the motion of a pendulum from one extreme position to the another extreme position. Extreme means we can say that they are the end points of the pendulum. And back is called a oscillation. For example, from this figure you clearly that consider that if A is the rest position or the mean position of the pendulum. Okay, from this position the pendulum starts its motion. So the pendulum first goes from A to B and then again it comes back to A. So when it performs this motion, means from A to B and then again back to A, then we can say that it is performed one or the pendulum perform the one oscillation. So the one oscillation is nothing but the motion of the pendulum. This is the one extreme position, this is the another extreme position, right? So from this one extreme position to the another extreme position and again come back to their previous extreme position. So this motion or this is called the oscillation. Okay, so simply it is a oscillation of the pendulum or an any object. Now, the term is the amplitude. It is a one property of that the wave. We already learned about that. The sound is a kind of wave. Sound travels in the form of wave. So, first, what we can say that the amplitude. So, the amplitude is nothing but the maximum displacement traveled by the particle from its rest position or its mean position. We already learned about this, the form of wave. This is the wave. Means always the sound traveled in this form of wave. Here you can see, you are able to see that the horizontal line x-axis represent, it is the mean position of the wave and this is the y-axis. So this is the mean position. The uppermost part is called the crust and the lowermost part is called the trough of the wave. Okay, this part is called the crust and this part is called the trough. So the maximum displacement traveled by the wave from this mean position is its amplitude. Either the distance traveled from mean position to the crust or to the trough. Means, or we can simply say that the amplitude of the sound wave is the height of the crust or trough. Whatever the height of the crust from the mean position or whatever the height of the trough from this mean position or rest position is nothing but its amplitude. This is in the form of wave. Now in the form of the oscillation, we can say that the maximum displacement. Now consider that this is a pendulum. The rest position or the mean position of this pendulum is O. Okay, so the pendulum starts its motion from O to A, okay, or either to O to B. So O to A or O to B is the maximum displacement performed by this pendulum is called its amplitude. So here we can say that the maximum displacement of an oscillating body from its central position or from its mean position is called its amplitude. Means here OA is also the amplitude and OB is also the amplitude because it travels a maximum distance from its mean position. Here also from the central position or from the mean position, it travels a maximum distance, means the height of the crust, or the maximum distance towards the downward direction, means the height of the trough. So it is the amplitude. It is represented by the letter, sometimes it is represented by capital A or small a. And the amplitude is nothing but the displacement. So we can measure this amplitude in meter or in centimeter also. Okay, so this is the one most important property of the wave, which we call the amplitude. Now the second one is the frequency. Now what is the frequency here? Frequency is also the very most important property of the wave. So the frequency is nothing but the number of waves. See here that these are the number of waves. One wave complete from this position. This is the starting position of the wave. From this position it starts, it goes up and then come back down, and at this position, this is the one cycle. Okay, this is the one cycle, or we can say that this is the one wave. So here is the one wave, here is the another wave, here is the another third one wave, and the fourth one wave. Okay, so this number of waves or number of cycles performed by the particle per second, right? How many cycles performed by the particle, or how many waves performed by the or produced by the particle per second is called its frequency. This is simply the frequency. Means in a 1 second, how much waves performed by the particle or how much cycles produced by the particle is called its frequency. In terms of oscillation, we can say that the number of oscillations performed by the oscillating body, means from A to B and again B to A. This is a one oscillation. Again A to B and again B to A. This is the another oscillation. So number of oscillations performed by the oscillating body or by the particle per second. This is called the frequency. Okay, the frequency in terms of the wave, number of waves produced per second, or the number of oscillations performed by the particle or the oscillating body per second. Means in a 1 second, how many cycles are traveled by the particle or how many oscillations performed by the particle is called its frequency. So the frequency is denoted by mu. Mu is the Greek letter and its a symbol is this. It is called a mu. It is a Greek letter. Also, it is represented by the F also. Sometimes it is also represented by the small n also. And the unit of frequency is hertz. Always the frequency is measured in hertz. Hertz is the standard unit for measuring the frequency. Okay, so this is about that the frequency. Now the next one term comes is the time period. Time period is also the another property of the sound wave. So the time period is what? The time required to complete this one cycle, means one crust and one trough make a one cycle or make a one wave. Okay, this is complete. Here is a one crust and the lower half part is called a trough. So the one crust and the one trough make a one wave. So the time required to complete this one wave or the time required to travel this one cycle is called its a time period, right? So the time required to complete one oscillation also we can say that. Here the oscillation is means from if it starts from A to B and again back to A. This is the one oscillation. So how much time it requires to complete this one oscillation is called its time period. So the time period is denoted by capital T always. Okay. So make a difference between that the frequency and the time period. Okay. Frequency is the number of waves or number of oscillations performed by a particle per second is called a frequency. And the time period means the time required to complete the one wave or to complete the one cycle and the to complete the one oscillation. Okay, whatever the time required to complete this one oscillation or one wave or one cycle is called its time period. There is a one relation between the time period and the frequency. So the relation between the time period and the frequency is the inverse relation. Means time is always inversely proportional to the frequency. If the time increases, the frequency decreases. If the time decreases, then the frequency increases. Okay, so there is an inverse relation between the time and the frequency, and the SI unit for measuring the time is of course the second here, not a minute, not an hour. So the SI unit for measuring the time is second. Okay, this is about the time period. Now the next one property of the wave is the wavelength. Now what is the wavelength? Wavelength is nothing but the distance between the two consecutive thrust, either two consecutive trough. Okay, this is the distance between either two consecutive thrust or two consecutive trough. This is called its wavelength. Means one complete cycle. Okay, means we can also say that the distance between the two consecutive thrust to consecutive trough, or the one thrust and a one trough makes a one cycle. So this is also called a wavelength. It is the distance between the two consecutive thrust or two consecutive trough. Okay, this is called the wavelength of the wave. It is denoted by the symbol lambda, and it is measured in the meter or centimeter because it's also a one type of the distance we can measure. So amplitude is the height of the thrust and the trough, and wavelength is the distance between the two consecutive thrust or two consecutive trough is called its wavelength, which is denoted by the lambda. Okay. Now the term comes loudness and pitch of the sound. Now these two terms are related with that the property. The loudness is related with the term amplitude, and the pitch is related with the term frequency. Now what is the loudness? Loudness is simply the characteristic of sound, and it is the degree of sensation of sound. How much amount of sound you are able or you are able to hear, or you are audible. Okay, this is the depend on the amplitude of the sound, which we can say that it is a loudness. If if the amplitude is less, okay, then you hear sound is a feeble sound. But if the amplitude is more, the sound is a loud sound. So it's completely depend on the amplitude. If amplitude is greater, the sound is greater, the sound is loud. But the amplitude is less, the sound is feeble. And the unit for measuring the loudness of the sound is decibel, which is denoted by the dB. Okay, decibel is the standard unit to measuring the loudness of the sound, and it depends on that the amplitude. Now, the second is the pitch of the sound. Pitch of the sound is depend on the frequency. Simply, it is the property that determines the shrillness or deepness of the sound. Here also, if the pitch of the sound is or the frequency is more, means the voice is a shrill, and if the frequency is less, then the sound is a deep. You can also see from that figure, if the frequency is less, what we can say that the frequency, the number of cycles performed by the particle per second. Here in a per second, the number of cycles are 2 only. And here in a per second, the number of cycles are 1, 2, 3, 4 and 5. Okay, means here the frequency is 5 hertz, and here is the frequency is 2 hertz only, right? So here the frequency is low, so the pitch is also low, and the voice is deep. Okay, for example, the sound of a drum, the sound of an adult, then the roaring of lion, they are all the examples of the less frequency and the high and the low pitch. Here the frequency is maximum, means here is a high pitch. If the pitch is high, if the frequency is high, the voice is a shrill. For example, the sound of a whistle, the sound of a baby, etc. These are the examples of that the low pitch and the high pitch. And simply we can say that the pitch is depend on the frequency. If the frequency is more, the pitch is more, and the sound is shrilled. But if the frequency is low, the pitch is low, and the sound is deep. Okay, so this is the about the pitch of the sound and the loudness of the sound is depend upon the amplitude. Okay, so in today's class, what we learn about that? We learn about the oscillations, right? We learn about the amplitude, we learn about the time period, frequency, wavelength, loudness, and pitch of the sound. So the oscillation is nothing but the motion of a particle from one extreme position to the another extreme position and again back to its position. Right? This is called its oscillation. The amplitude is nothing but the height of the crust or the height of the trough, or simply we can say that the maximum displacement traveled by the oscillating body, or a maximum displacement traveled by a particle, is called its amplitude. Then the frequency is the number of cycles or number of waves or number of oscillations per second is called its frequency, which is denoted by mu, and it is measured in hertz. The time period is the time required to complete the one cycle or to complete the one oscillation is called its time period, which is denoted by capital T, and it is measured in second. And the relation between the time period and the frequency is always inverse. T is inversely proportional to mu. Okay, if the time period increases, the frequency decreases. If the time period decreases, the frequency increases. Then the wavelength. The wavelength is nothing but the distance between the two consecutive either crust or two consecutive trough, or the one complete wave or one complete cycle is called its wavelength, which is denoted by the symbol lambda, and it is also measured in meter or in centimeter. Now we learn about that the pitch of sound and the loudness of the sound. So the loudness of the sound is a depend upon the amplitude. If the amplitude increases, the sound increases. If the amplitude decreases, sound also decreases. And the pitch of the sound is depend upon the frequency. So if the frequency increased, means there is a high pitch and the voice is shrill. But if the frequency decrease, means there is a low pitch and the sound becomes deep. Okay, so these are all the properties of the sound which we learned today. So in the next class, we will see the structure of the human ear, the audible and the inaudible sound.